Hello everyone. GenAI is the buzzword these days. In this video, I will be talking about AI, ML, and GenAI, relationship between them. Then further, I will try to explore how can AWS help generative AI or GenAI. Over the last several years, machine learning has rapidly expanded the capabilities of AI in the world of IT. Today, that expansion has entered the domain of GenAI or generative AI. Gen AI is making it easier to innovate faster and reduce the number of hours needed for development. This provides you with more time to grow your business. If you look at the diagram, you can clearly see how we started with AI and how we have grown with time. Artificial intelligence is the concept of creating smart, intelligent machines. Machine learning is a subset of artificial intelligence that helps you build AI driven applications. Deep learning is a subset of machine learning that uses vast volumes of data and complex algorithms to train a model. And generative AI creates new content. Thus, Gen AI or generative AI is a type of AI that can create new contents including videos, stories, music, images, conversations, etc. Before we move ahead with our discussion on Gen AI, I would love to take a pause here to tell you that I have already created a video before on machine learning and its type with examples in detail. You can go ahead and explore it anytime. So, Tom McHale defines machine learning as a computer program set to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. For instance, suppose you have an email program that learns and filters which email is a spam and which is not a spam, and based upon learning better filter spam. Here, T or the task equals classifying emails as spam or not spam. E equals watching you label emails as spam or not spam, and P or performance equals to number or fraction of email correctly classified. When we talk of ML type or machine learning type, supervised learning requires labeled data set for training. Unsupervised learning identifies hidden data patterns from an unlabeled data set, whereas reinforcement learning does not require any data as it learns by interacting with the environment. Coming to online learning is quite unlike your batch learning, which is done incrementally. Online learning is commonly used in situations where data is too large to be processed all at once, or where data is constantly changing, such as in stock market data or your social media data. Whereas batch learning, also known as offline learning, involves training a model on fixed data set or a batch of data all at once. Coming back to your Gen AI, the very first question that comes to our mind is how does Gen AI or generative AI actually differs from your traditional AI? So the core of Gen AI is a foundational model which we call as FMs, which are a class of ML models pre-trained on vast amount of data to perform wide range of tasks. These tasks include text generation, data summarization, information extraction, question and answer responses, and chatbot interactions. In contrast, ML models are trained to perform specific tasks from a dataset. Gen AI's foundational models accept statement as prompt as input, make inferences, and finally return an output. For instance, you have Amazon Code Whisperer, which uses Gen AI to make inferences and generate code as output. If we compare your traditional and foundational model, so in short, what we can say is traditional models perform tasks based on data that we provide, whereas Gen AI models are pre-trained on vast amount of general domain data. Again, traditional ML models can perform only one task, whereas Gen AI models can perform multiple tasks. Traditional models need to be carefully trained on the data you provide, whereas your GenAI models can actually generate content. Generative AI का जो GenAI, what we say, is from this generation only. Moving ahead, the other thing that comes to our mind is what are the different types of foundational models? Coming to types of foundational models, we have basically three types of foundational models: text to text to embeddings, and multimodals. Text to text foundational models are built for NLPs or natural language processing tasks that are developed by ML research community, startups, and established companies. Many organizations have had a chance to experiment with generative large language models, what you call in short LLMs, that can do things like summarizing the text, extracting information, responding to questions, and creating contents. These models take a user's input text and extend it with new generated text. For instance, sentence auto completion. Suppose you are inputting something like summarize the articles on impact of walking on heart health. FN action will be generate the text from the NLP prompts, and you can get output something similar to like 10,000 steps per day is optimum for maintaining a healthy heart. This is an example of text to text type of FMs. Coming to text to embeddings, text to embedding functional model are another type of LLMs that can compare piece of text like input, like what a user types into search bar with index data and makes a connection between the two. Amazon's product search uses these types of LLMs to compare users' tasks with catalog data and present the user with more accurate, relevant search. For instance, you can have something like if you are inputting in hand soap, FM action will be to generate numerical representation of the text, and you might get an output something similar to hand soap refills, hand soap dispensers, hand soap, antibacterial soaps, and so on. Coming to your multimodal functional models can understand and generate different formats such as text and images. These types of functional models or FMs can generate images based on NLP prompt. An example of this is a stable diffusion. For example, you are inputting a photo of an astronaut riding a horse on a Mars. FN model action could be create and edit image using NLP prompts, and you can get output something as similar as shown on the screen. Thus, we can see that we can use generative AI to enhance customer experience, boost employee productivity, optimize processes, enhance creativity, and even create or generate contents. Now, coming to the major question, what is the benefit of using AWS for GenAI? Or, in other words, how can AWS help GenAI? With GenAI or generative AI on AWS, you get enterprise grade security and privacy, access to industry leading FMs or functional models, generative AI powered applications, and data first approach. You can choose from range of GenAI technologies that support all types of organizations in every stage of GenAI adoption and maturity. For instance, with Amazon Code Whisperer, now called Amazon Q Developer, an AI coding companion, you can get great results in developer productivity. During the preview, Amazon ran a productivity challenge. Participants who used Code Whisperer were 27% more likely to complete tasks successfully. On average, they completed tasks 57% faster than those who didn't use Code Whisperer. Thus, code generation is one of the most promising applications for GenAI. Similarly, we have Amazon Bedrock. Bedrock is another fully managed service that offers a choice of high performing FMs and broad set of capabilities. You can easily experiment with various top FMs, privately customize them with your data, and create managed agents that execute complex business tasks. Then you have Amazon SageMaker Jumpstart. You can use it to discover, explore, and deploy open source FMs or even create your own. SageMaker Jumpstart provides managed infrastructure and tools to accelerate scalable, reliable, and secure model building, training, and deployment. You have Amazon Health Scribe. Amazon Health Scribe is your HIPAA eligible service empowering healthcare software vendors to build clinical application that automatically generates clinical notes by analyzing patients' clinical conversations. Amazon's Health Scribe combines speech recognition and generative AI to reduce the burden of clinical documentation by transcribing patient clinical conversation and generating easy to review clinical notes. How good is that? Similarly, we have Amazon Q in QuickSight, which helps business analysts create easily and customize visuals using NLP commands. The new generative BI authorizing capabilities extend the natural language querying or quick site queue beyond answering well structured questions such as what are top 10 products sold in California to help analysts quickly create customizable visuals from questions fragments such as the top 10 product. Classify the intent of query by asking fellow questions and refine visuals and complete complex calculations. Next, we are going to see what does end-to-end machine learning project actually look like and how we can choose from broad set of AWS ML services at each stages. Traditional ML development is a complex, expensive, and iterative process. First, you need to prepare example data to train a model. Then, developers need to select which algorithm or framework they will use to build the model. Then, they need to train the model on how to make predictions and tune it so that it delivers the best possible prediction. Finally, they need to integrate the model with their application and deploy this application on infrastructure that will scale. It generally has following steps. First, frame the problem and look at a bigger picture. Second, get the data. Next, explore the data. Then, prepare the data for ML algorithms. Explore different models and shortlist the best one. Fine tune the model. Present the solution. And finally, launch, monitor, and maintain the system. So, now we will see how to choose from the broad set of AWS ML services which are available to assist us in different stages. Starting with Get. AWS services offer compelling solutions to quickly and accurately classify, extract, and analyze the data. Amazon Textract, Amazon Comprehend, Amazon Augmented AI, and Amazon Kendra. With Amazon Bedrock, you can use to easily embed AI-powered functionality from Amazon Textract and Amazon Comprehend into business workflow and application. The data science team can be engaged for FM selection, evaluation, tuning based on GenAI use cases and link generative AI and FN modules with AWS IDP through chaining from example to create an end-to-end document processing pipeline. Coming to prepare the pre-processing data, you typically fetch the data in repository, clean the data by filtering and modifying your data so that it is easier to explore, prepare or transform the data into meaningful data set by filtering out the parts you don't want or you don't need and labeling the data. In this section, Amazon SageMaker Ground Truth automates labeling by training ground truth from data labeled by humans so that service learns to label data independently. Amazon SageMaker Processing extends a fully managed experience to data processing workload. connect to existing storage or file system data sources, spin up resources required to run your job, save the output to persistent storage and examining the logs and metrics. We have Amazon EMR, which processes vast amount of data quickly and cost effectively at scale. We have Amazon S3, which offers global availability of long-term durable storage of data in readily accessible get put access format. Coming to build section, once you have training data available, you need to choose a machine learning algorithm with learning style that meets your need. These algorithms can be broadly classified as supervised learning, unsupervised learning, or reinforcement learning. We have already talked about. To assist you in your development of your model, different machine learning frameworks such as TensorFlow, PyTorch are available with libraries and tools to make development easier. We have Amazon SageMaker. From sharing and collaborating in Jupyter Notebook to algorithm creation, and leading frameworks are automatically configured and optimized for high performance. You don't need to manually set up frameworks, and you can use them within the built-in containers. You have Amazon's AWS deep learning containers, which can be used to quickly deploy deep learning environment with optimized pre-packaged container images. Coming to next section, which is training of your algorithm. After building your model, you need compute, networking, and storage resources for training your model. Faster models training can enable data scientists and machine learning engineers to iterate faster, train more models, and increase accuracy too. After you have trained your models, you evaluate it to determine whether the accuracy of the inference is acceptable. EC2 TRN instance powered by AWS Titanium powered by AWS Titanium chips for time and cost sensitive large scale training help us in doing so. We also have EC2 DL1 instances powered by Habana Gaudi. They can be used to set up Gaudi 8 accelerators and deliver up to 40% better price performance than your current GPU based EC2 instance for training deep learning models. Then you have Amazon EC2 P4 instances, which are meant for your time-sensitive large-scale training. P4D instances are deployed in hyperscale clusters called EC2 Ultra clusters that provide supercomputer class performance for your everyday ML developer, researchers, and data scientists. You have Amazon EC2 G5 instances. These are your cost sensitive small scale training G5 instances which deliver up to 3.3x instance higher level of performance for machine learning training as compared to your G4 DN instances. Coming to your deploy section, once you have completed training and optimized your model to your desired level of accuracy and precision, you put it to production by making predictions. Inferences is what actually accounts for vast majority of machine learning cost. According to customers, machine learning inference can represent up to 90% of your overall operational cost for running machine learning workloads. So with Amazon Elastic Inference, we can have right sizing inference, acceleration for optimal price and performance. With AWS Outpost, which is a fully managed service that extends your AWS infrastructure, AWS Service API, and tools to your virtually any data center, co-location space, or any on-premise facility. We can make use of AWS CloudFormation, which allows you to use programming language or simple text file to model and provision in an automated and a secure manner all the resources needed for your application across region and account. Finally, we can also make use of your AWS autoscaling. AWS autoscaling monitors your application and automatically adjusts capacity to maintain steady prediction and performance at lowest cost possible. We have Amazon SageMaker Model Monitor, which continuously monitor the quality of machine learning models in production and receive alerts when there are deviation in model quality with building additional tooling. We have Amazon SageMaker multi-model endpoints, which deploy multiple models with a single click on a single endpoint and serve of using single serving container to provide us a scalable and a cost-effective way to deploy large number of models. Thus, we can see that organizations that want to develop their ML model can use various Amazon tools